Greetings everyone, this is Professor Jeff Wilkerson at Luther College bringing you the next in our series of what to look for in the night sky. We're talking about November 28th, 2022 this time around. So this, we're going to focus on the region around Taurus. And we've looked at Taurus several times before. We're going to talk about Mars. Mars is sitting here in Taurus, and we'll make this a little clearer in a moment. But we'll return to this. So first of all, we'll probably briefly return to this next week when we talk about the night sky, because the moon is going to come zipping right by Mars next week. This week, on the evening of December 1st, Thursday evening out there, we will see the moon right by Jupiter. So be sure to check that out as it gets dark on the evening of the 1st. See if you can go outside. Hopefully you have clear skies and you'll be able to see the moon sitting just below Jupiter, making a really nice bright pairing in the evening sky. That'll happen again several days later with Mars. So as it gets dark, Mars and Taurus and this whole region of the sky are climbing into the eastern, over the eastern horizon. So you wait for a couple hours after dark, and they should be well up into the sky and easy to see, if they're not already easy to see, as it gets dark. So we have the bright orange star Aldebaran, as we've talked about many times before, the eye of the bull. So we have the Arabic word for the eye of the bull there. And Aldebaran is part of the V of the Hyades, a nice open star cluster. Check out that open star cluster. Count the stars. See what stars you can see. Use your binoculars. See what other stars you can see. The Pleiades is up this direction, about 13 degrees north and west of the Hyades. Another really big, bright, open star cluster that looks like a little tiny dipper of stars. See if you can see 5 or 6 or 7 stars without optical aid. Use your binoculars and count all the stars that you can possibly count in there. And then if you have a telescope, you can probe around there a little bit more, but you need a really low power wide view to be able to take that in and see it. If we extend the upper part of the V of the Hyades out this direction, we just miss Elnath, a fairly bright star out this direction. Mars is going to be the biggest, brightest object in the region, and it's about 11 degrees from Aldebaran up this direction, and it's about 5 degrees from Elnath. So it sits just past the halfway point between Elnath and Aldebaran. So check that out right now. And then watch Mars. We suggested maybe you wanted to try to do this earlier in the fall. Mars is in a retrograde loop. We're catching up and passing Mars in our orbit. So Mars, normally stars track easterly against the background stars. Mars is tracking to the west. And by mid-January, Mars will have moved up this direction. So we've just got, over the next month and a half, maybe, less than that, really, Mars is going to move from here to here very noticeably, where it's sitting directly above Aldebaran. So instead of sitting over toward Elnath, it's going to look like it's straight up above toward, by the Pleiades. Mars will have moved over the next month. So it's really, really good to watch this through the month of December. This retrograde motion is noticeable. By the time we get through January, it's going to turn around and start prograde motion again back to the east. So we'll keep an eye on it all winter long. Something good to do. For right now, one of the things that we want to think about as we're thinking about this retrograde motion is just about 7 degrees, forming a sort of isosceles triangle with Elnath, Mars, and Mars. About 7 degrees out here on the point is M1, the Crab Nebula. And the Crab Nebula is the remnants of a supernova that exploded in the year 1054. Big, beautiful supernova in the year 1054. And this is one of the best examples of a supernova remnant we have in the sky. It's possible with really good binoculars you can see this smudge of light. It's going to be a lot better in a telescope. So if you have a telescope and you want to get out there, you're going to see this sort of thumbprint of light that's right here. That's the remnants of this explosion of a star. This is a star that is at least 8 times the mass of the sun, maybe more than that. Unique, because stars at the end of their life, they're shedding mass. They're blowing mass out into space. And if they don't get enough mass blown out into space, so you've got to say a star that's 10 times bigger than the sun. It has enough pressure and to cause the core to collapse. So the core is supported by electron degeneracy. This is a quantum statistics thing. This is an overlap of quantum wave functions that's going on in the core of this star. And the electron degeneracy can be broken as the temperature gets too high from material sort of precipitating down in that core. And you've got this hot pressure right there, and the core's getting the core collapses. And when the core collapses, the degeneracy pressure is broken. Everything starts to fall inward, and it falls in until neutron degeneracy takes over. The overlap of neutron quantum wave functions takes over, and it stiffens, and everything bounces off that core and bounces back out, and you get this core rebound that destroys the star. And that's what happened here in the year 1054 with this supernova explosion. And so we see the remnant of that Crab Nebula right now. Beautiful example, one of the best examples of a supernova remnant. Now, if you're not heavy enough to do that, and most stars aren't, the vast majority of stars are not massive enough to end their lives that way, you end up becoming a planetary nebula. And a planetary nebula happens when you've got hydrogen burning shell, hydrogen fusing into helium and precipitating onto a helium core, or let's say precipitating into a helium burning shell. The helium is making carbon, and that carbon, these things aren't going on so much at the same time. You're toggling back and forth between which shell is providing you energy. So you got a hydrogen shell making helium. That feeds a helium shell. That helium shell can turn on and make carbon, and that can feed a carbon, nitrogen, oxygen core. And so you got this core that's going to be a white dwarf star in the middle of that star. And as this happens, the core of the star is getting hotter and hotter, and it's pushing the outer layer of the star. The pressure's going up, and it's pushing the outer layer of the star further and further and further out. And the surface of that star is getting pretty tenuously held. And you've got all of this sort of explosive fusion going on with shells turning on and off and on and off. And pretty soon you lose the surface of that star, and it just blows out into space, and it starts expanding away. A much gentler, not a gentle process by any stretch, but a much gentler process than this. And that makes something called a planetary nebula. Terrible name. It has nothing to do with a planet. It just kind of looks like a planet in a telescope. And there is an example of this in Taurus as well, NGC 1514. And so this is a planetary nebula in Taurus. We see a supernova remnant you can check out. You got your telescope. Try for NGC 1514, but it is going to be a challenge. It's not one of the most easily recognizable planetary nebula. It has the white dwarf in its core is pretty bright, so you can see the white dwarf star better than you can others, but the gas around it's pretty tenuous. If you got a 10 or 12 inch scope and a good dark sky, probably you can start to make this out a little bit. If you got a 15, 14 inch scope, so much the better, right? If you've got a 16-inch scope, I think you can do this for sure. If you have a CCD camera and you're taking pictures of the region of the sky, you get some nice pictures of NGC 1514 for sure. This sits about 8 degrees above the Pleiades, and Mars is headed more or less right toward it. It's a little bit south of right toward it, but Mars is going to be aiming right in that direction of NGC 1514, our example of a planetary nebula, this lower mass star that has ended its existence here. And so we see its gas puffing out into space. Maybe the most famous NGC 1514, William Herschel discovered it. William Herschel was a great observer and discovered Uranus, and so was lots of other things he did. But perhaps what makes this most famous is that he discovered this nebula, and it was the first nebula that convinced him. Up to that time, he and most people thought that nebulae were just unresolved stars, that you just had a cloud of stars, and they were made of individual stars, but they were so far away and so close together, they merged into a uniform glow of light. And he decided here, seeing that bright star in the middle and the haze of gas around it, he decided, maybe not. Maybe this is just actually a gas cloud, which it is, with a central star right here, and sort of changed the way we started thinking about nebulae going forward. So that's what we got for you for the week of November 28th, 2022. Great things to do. Watch the Moon by Jupiter on December 1st, and then start to watch this guy. Keep your eyes on Mars as it's tracking pretty well to the west against the background stars, and check out the Hyades and the Pleiades, these beautiful open star clusters. And if you've got a good telescope and you're up for a challenge, check out the Crab Nebula, and particularly challenge NGC 1514 as a planetary nebula, and think about these stars. that have sort of reached the end of their existence. Hope you have a great week, everyone. Hope you have dark skies and clear skies, and we'll have more for you next time around. As always, thanks for watching.